Thank you very much, Campbell, for taking the time for this interview. Very happy. And how are you today?
I'm good. Thank you for inviting me. I'm looking forward to talking about XULE.
Good, good. We will indeed talk about XULE, but before that, maybe we can start explaining a little bit the contest, and maybe you can talk a little bit about yourself and your organization.
Right. So just to give you some background, so XBRL is a global standard for reporting financial data predominantly, and it's used pretty much in most countries around the world. Across Europe, there's a big rollout of XBRL for public companies at the moment. It's used heavily in Asia and in the United States, and also in Latin America, and also the Middle East. It's predominantly used by banking regulators and securities regulators, but it's also used by tax regulators as well. And the main purpose of it is to collect financial data. And this might be things that you're familiar with, like a balance sheet, income statement, cash flow, that kind of information, anything which is used to measure the performance of a business. So that's what the XBRL standard is used for. And throughout the world, there are a number of different jurisdictions who try to help people adopt XBRL. And in the US, where we're based, that's what we do. So we predominantly help people like the SEC, which is the securities regulator here in the US. We've also helped the Federal Energy Regulatory Commission. They're the regulator who regulates the utilities industry, or the electric, gas, and oil pipeline business. So they collect financial data from their regulated entities, and also a banking regulator called the FDIC, which is responsible for ensuring bank deposits in the US. And so they collect a lot of financial data as well. So all of these entities are using XBRL to collect data. And once they collect it, then they make it available to people to use. So that's kind of what we do as XBRL US. We help those regulators do it, but we also help people file to the regulators. And we do training and provide tools and trying to build a community for people to do that. XBRL US itself is a not-for-profit. We basically report into XBRL International, which is also the global organization which is responsible for the XBRL specifications. So they basically will publish out the XBRL spec, which some of you may or may not be familiar with. You can go to their site, you can see all the specifications. And and all those specifications do is really define a format about how a company should report their financial data to another entity who is collecting it. Usually a regulator, but it could also be anyone who's collecting financial data, which, lots of people do that. The insurance industry does it, or private equity, or whoever it is. So the standard can be used for many purposes other than those ones I just discussed. They're just the main users globally.
Yeah, and for example, Strumenta is a small Italian company, but after we talk, I look into XBRL and I realized that, for example, our financial data that must be public. I mean, this is the case for all companies in Italy, has been also specified with this format, and yeah, so it's quite widespread. Good, good. So I think you already covered what is the format, who is using it, and what is the purpose. So I think you laid the perfect context to now explain what XULE is.
Right. So one of the things that we've tried to do, one of our missions, one of our core goals, is to try and make a lot of this XBRL data available to as many people as we can. And in the US, predominantly that's investors, but also we want to make it easier for regulators to use that data as well. And we undertook a number of initiatives. The first initiative we undertook was to basically start collecting all this data and then make all that data available to folks out of a database. And we made an API, and you can go and look at that. So you can bring the data back and you can look at it in things like Excel or any other tool which can talk with an API and build an application, etc. One of the things that we found with all of this data that's been collected, the data, unlike traditional data formats or traditional data that's collected, financial data is very, very complicated. And so there's a lot of complexity there. So to be able to collect this data and collect it accurately can become problematic. So one of the things that we wanted to do is to try and improve the quality of the data that was being reported to folks like the SEC. And the SEC is a little bit more complicated because companies have the option to basically go and define their own metadata, which allows them to report things that may be unique to them. So if you can imagine, you've got a model, you've got a data model that the SEC publishes with the financial regulator, which is called the FASB here, the Financial Accounting Standards Regulator. They basically then define a model and they say people have to report on it. But they do give companies the option to extend that model so they can then take the model, add some additional metadata to it, and then report to the regulator. And that's what's happened in the US. That's also happening in Europe as well. And this is typically done not by banking regulators, but mainly by securities regulators. So if you want to understand the data that's being published, you need to be able to navigate these models. You need to be able to read them, and you need to be able to apply logic to them. So one of the things that was published by XBRL International was something called XBRL Formula. And this is a way so you can define, formulaic relationships between data and also metadata, and use metadata to define those. There are a number of deficiencies in XBRL Formula. Well, not deficiencies, just scope areas that it didn't cover. The standard was also defined as an XML format, so it was a little bit difficult to express and to debug. So one of the things that we wanted to do was to basically write a rules language for XBRL so that we could then write a lot of these rules a lot faster and a lot more efficiently, make debugging of those rules easier as well. So we came up with something called XULE, which is really short for XBRL rules. So that's why it's called XULE. And then the syntax was really designed in a way to make it as easy as possible to write, but at the same time make it easy to debug and to understand and to take up as little, to be as precise as we possibly could. And one of the underlying drivers for that was, in theory, was to make it possible so accountants could write these rules and they could read them, or any other person who was like a data scientist, they could read it without necessarily having to go and learn a complex programming language to read this stuff. Secondly, we wanted to put a lot of functions into the language so that it would make navigating the XBRL model very easily and intuitive. So that was the genesis for doing this. That's why we did it. It was really to get data quality. As we'll talk later, it actually has a lot more uses than that as well.
If I understand correctly, a lot of companies and institutions provide their financial data in this format. And so it's very interesting to be able to access this data and to process it for very different actors. I guess, for example, well, for tax purposes, maybe one want to do some calculation, but also someone may want to process this data to assess the financial health of a company, or maybe even for internal usage to understand how the company is going, maybe calculate indexes and guide decisions based on this data. And I understand that originally was created XBRL formula that is written in XML, so it's a format that is great for machines, but you instead wanted also to provide a language that is more user-friendly so that these many different actors can use it to actually process the data, to query it, to calculate values and get information out of this data.
And one of the other issues I didn't really mention with XBRL formulas is we've written it, it's in XML, but it expects to some extent the data that is provided to be in an XML format as well. Now, XBRL has kind of moved on and it's tried to remove or separate more clearly the semantics and the syntax of the model. And so XBRL specification has evolved. So now you can get data, XBRL data in a JSON format, or you can get it in a CSV format. It has something called inline XBRL, which is effectively XBRL data in a HTML format. So the XBRL formula, when it was first written, has a lot of syntactical artifacts in it, which refer to XML type constructs. Whereas when we did the XULE language, we tried to remove as much of that syntactical reference as possible, so that if XULE would work with whether the data was submitted in JSON or CSV or HTML. And so it works fine on any of those different, if the data is provided in that different syntax, it doesn't really matter. There's no real artifacts in the XULE language that directly references them. I say that there are some that sometimes you want that data for a specific purpose, but we try to avoid putting that into XULE at all, so that we're not in a position where you rely on the format being in a particular syntax.
Yeah, because I understand that the people who have the competence to ask the right questions are typically not developers. They're accountants, people that understand about finance or taxes. So yeah, probably they are not XML experts, and so if we can provide things in a way that is more user-friendly, we make their life easier. Can you tell us something about the design of the language, its history, who has created it?
So one of the, I used to work for Morgan Stanley, and one of the issues we'd had there was also similar. We'd tried to write languages to basically process this data. And one of the tricks of this is really processing multi-dimensional data. XBRL uses a dimensional model. And so how do you reference data that's, in a multi-dimensional structure, and then doing that in a way without being buried in hundreds of for loops? So that was kind of one of the underlying design principles, is we wanted to make it easier to pull multi-dimensional data and understand what those dimensions were. And at the same time, XBRL, you can think of it as, this is kind of really before graphs really came about, but it really is a graph. The XBRL model is really, it's based on links. So it's really linking nodes to other nodes with arcs, or networks, if you can think of it that way. So you have two parts to it. You have this network, which defines the model, and there's multiple networks which can define the model. How do things add up? How are things presented? What's the relationship between these two concepts? Is this a type of this? Is this a type of that? There's a lot of relationships that are defined in the model. But at the same time, you have a lot of factual data, which is then reported based on that model. And so what we tried to do is we said we really need a language which can allow us to access the model easily and allow us to access the facts easily, and then combine them together and then create different information. And the reason that's important is because you may have the same data being reported at multiple places, and you might have data reported, but one piece of data is a component of another piece. But if you want to add something up, you don't want to double count. So there's all this kind of complexity there, or you only want to add items which have equivalent decimal accuracy. So being able to understand which concepts relate to each other, and then what facts were reported to them, and how they're dimensionalized, you need to be able to manage all that. So XULE was initially designed, we sat down, I was in Guatemala at the time, and I think Philip Engel at the time, he was in California, and then we said, we really need to be able to address all these different things. And so we just sat down and went through everything that we needed to be able to do to address this. And we ended up with like a 100-page specification. Okay. It's very precise. It just dealt with all of the issues. How do we navigate these networks? How do we pull the facts out? How do we handle dimensions? What functions do we need? What properties do we need? What's the type of stuff that we're gonna need to be able to do? And we had a lot of experience with this in terms of looking at data that the SEC had reported, and looking at stuff that we had done at Morgan Stanley. And so we kind of knew what we needed and how we needed to pull that data out. So a lot of it was really just designing the syntax of a language. How can we do this in the most efficient way possible? At the same time, without having a syntax that was ambiguous. So that was kind of what we sat down and did. So we wrote this document, and then we said, let's try and implement it. So we built a parser, to do that. And then we wrote a processor in Python. And then that underneath it used a software called a RHEL, which is just like an open source XBRL processor. And then we basically, did the grammar, then we could compile those rules, and then we could run those rules. And then we went from there, and then we kind of gradually went through a whole bunch of use cases and refined it. And then we came up with this, a finalized syntax, and we had like a processor that basically worked, and then went from there and refined it. So that was kind of the history of it. So myself and Philip Ingle really spent a lot of time, on the design and then trying to get this thing to work.
Good. And is there any project you are aware of that is using XULE and that you think would be interesting to share?
Yeah, so there's a couple. One that we have implemented here in the US is we produce a number of data quality rules, which we publish, and we publish those rules as in the XULE syntax, as it's just in the raw syntax, but we also published a compiled version, and then folks can take those and then they can process those rules against a filing. So for example, let's say I'm a Fortune 500 company, and I'm going to report my filing to the SEC. We try to encourage people to run these XULE rules before they file with the SEC. They're freely available, so people can run them. And then what that does is they'll run them and they'll see if they've got errors in their filing. And if they do, then it gives them a message, this is the issue, this is probably what you should do to correct it. Then they can correct it, then run them again, and then if there's no errors, then I'll file it with the SEC. Now, this is initially what this is the initial design purpose of this that we wanted to achieve, because we wanted to improve the data quality of the filings with the SEC. There wasn't necessarily consistency across filers. So these rules were designed to do that. Now, the SEC had rules as well. They were really more, you can think of them as more like XBRL syntactical rules, has to be XBRL valid. But these rules are more like really looking at things like, does your balance sheet balance, or, have you paid out, does your cash flow calculate the way it should be? Have you added something when you should have been subtracting it? So it has a whole bunch of rules, or there's inconsistencies between these types of elements. We would expect the first quarter, second quarter, third quarter, and fourth quarter to add to the total of the year. So all of these things, these rules can be expressed in XULE, and then companies can run them before they file. And then that way they can improve the data quality. So pretty much, I would say, the majority of the, of the largest, like 2,000 filers are using these rules today before they file to the SEC. And then we're working with software vendors to integrate XULE into their software as well, so they can all run these things. So that's one. The other one is Federal Energy Regulatory Commission. They are also using XULE, and they're using that for validation, but they're also using it for rendering HTML documents. So, and this was never the intention of XULE, but actually works really well for doing this, so we create like HTML templates, and then we take the XBRL data, which is coming in an XML format, and then we take XULE, and it basically pulls the data out of the XML, takes data, it pulls it out of the taxonomy that they've published, and then it plonks it into a template, an HTML template, and then you can just open the HTML. So it's basically taking XML, it's acting like a style, like a FO type style sheet that some of you may be familiar with. But what's nice about it is if you make changes to the taxonomy or the model, then the rendered template is going to change. Or if you change the document, then that data will change. And if you've got the same data that's just reported on multiple schedules, you only need to change it once and it'll update it every year. So it's really just using the ability to read the taxonomy and read the instance style data, and basically take that data, manipulate it, and use it for something useful.
It's I think it is very inspiring to think that so much data is available in this format. So when you create some useful tool, for example, to validate the quality of the data or to present them in a readable format, you can operate at such a scale, and this tool can be immediately useful for, well, probably millions of companies across the world. So that's very inspiring. Yeah.
Yeah, the other thing we actually did it for, we used it because actually it was just the easiest way to do it. We had a taxonomy and someone said, oh, we want to publish as an open API using the Swagger format or open API format. And we wrote like a XULE rule that would take a taxonomy and output it as an open API, which is kind of interesting too. So it's just really a way to take data, reorganize it, and then output it based on all the input data that you've got.
We have talked about XULE, but one project also that you've created is the editor for XULE. And can you discuss about the goals of the project?
Right. So we initially started creating these rules, and one of the problems became, as the rules became more complicated and you wanted to do stuff, it became very difficult to, one, write the rules. You had to know, oh, there'd be an error, you'd go to compile it, you'd get a compile error, then you'd have to come back and you'd have to read through all this text and say, okay, where's the problem here? I can't find it. And trial and error. You know, and it might take, you might write a rule and it might take you several days to write this thing. And most of the time, 90% of the time was finding, oh, I put a mistake here, or I did a mistake there. So there was no real time, you know, you had to cycle through a compile cycle. So there's no IDE for it. So one of the things we said, you know, this is really bad. You know, this is just taking way too long. So we contacted Strumenta, who we had worked with in the past, because we had looked to do something, some other project with them, and we knew that they would do a good job, and we knew that they knew what they were talking about. So that was good that we had that contact. And so then we sat down with them and said, look, well, let's start this. We just really need to start with an editor, and then let's see if we can get that working, and so that we can actually start to write these rules. We can know they're valid before we actually compile them, and then we can, you know, save a lot of time in terms of going through this, you know, trying to debug these rules to get them right. And so that's what we did. And so we sat down and we went through, and I can't remember, like, it probably took like a month or 2 months, was it? You may remember better than I did, Federico. And we went through and we basically took the document that we've got, which basically defines all the syntax. And then we went basically through and we created this editor. Strumenta created the editor, and then we would go back and test it, and then come back and made us realize mistakes in our document. And we had a few of the fixes we found from going through that process. So that was actually very good as well. And what the editor did is it basically would color highlight everything, color highlight the functions and the fact sets and all these different aspects of this language. It also did checking against the taxonomy. So if you put a concept in and it wasn't an XBRL valid XBRL concept, it would highlight that for you. So then you could basically, you know, typos were a big problem, or, you know, sometimes there'd be elements in one taxonomy that didn't exist in a follow-up one because they'd be removed. So checking for all this became, you know, probably it increased our efficiency by at least 1,000%. Made a huge difference. This is one of the things that we did. I am so glad we did, because it just saved us so much time.
Good. I think when someone creates a language for someone who is not a developer, I mean, the bar is much higher. I mean, unless you build these tools to help them, it's difficult because it's not their profession to learn the language. So, and maybe they don't use it every day. So, you know, if they can have a tool helping them, it can, help them getting started.
It makes a huge difference. And just, you know, we have the autocomplete on there, so that's really useful. So it can autocomplete for elements. You don't have to go and look them up. It's just like so many savings across the board. And, you know, we try to, you know, when we write rules without using the editor, it's almost, if you try and do that, you know, I always go and copy and paste a rule that's not in the editor, just even to check that the rule's right, rather than even go through the parser. It's just easy to go through the editor. And it's also because it's color coded, it makes it easier to even think about the problems, and just the process of writing a rule just becomes easier, because you're not consuming bandwidth with worrying about getting everything to work.
Good. So at this point, we could show a demo of the editor.
Hi, this is David from XBRL US, and today I'm going to show you how to get started with the XULE editor. It's an extension for Visual Studio Code that provides syntax highlighting and code completion for the XULE syntax. The XULE syntax is used to write things like data quality committee rules. It also has the capability of writing reports based on XBRL data. I've got a DQC rules folder on my desktop. Inside of that DQC rules folder, if you tree in to the source folder, it then breaks down to IFRS and US GAAP taxonomies. And inside of that year 2020, I find a number of XULE files. These XULE files can be opened with something as simple as Notepad and read, although it might be kind of difficult to edit those files unless you knew something about the XULE syntax. You can find out about the XULE syntax by coming to our website and just typing in XULE XULE in the search bar. Visit the first page. There's a brief primer on it and full documentation provided as well. But for right now, let's try to get this editor installed. We'll go to the marketplace, search for the XULE editor, click the install button. Once it's been installed, you could open that same file. What you would find is that it's the same visual as Notepad, just in a dark background here. It would be white text on a black background. In order to enable the syntax highlighting and the code completion, you need a set of files that's on this page a little bit further down in a zip file. It's called DQC XULE settings. You want to download that as well and extract that file. I have it right here on my desktop, so I'll extract it. And then at that point, the only thing I need to do is to copy these folders and place them in the DQC folder. But first, let's take a look at what's here. There's a code workspace file. That code workspace file has a relationship with some of the settings JSON files that are in the taxonomy folder structure. And in addition, there are some taxonomy files in JSON format. These JSON files all work together to provide the syntax highlighting and code completion that is part of the XULE editor. So now we'll go back to the root of the DQC settings zip. We're going to copy these two folders, and we're going to find that same location where the source folder is, and I'm just going to paste it. Now I have those taxonomy JSON folders, or excuse me, JSON files, as well as the DQC workspace. So if I close these up and then open that workspace from inside of Visual Studio Code, the system reloads and I see all of the XULE files. The nice thing about it is when I open one of those XULE files, I get a presentation of the XULE code that has some syntax highlighting for me and also does some things like code completion for some of the taxonomy elements that may be referenced in these XULE files. So that's it. That's how to set up your XULE editor inside of Visual Studio Code and apply the settings file that's also available from the extension download page.
Okay, now maybe we can discuss how can people get the editor and how can people learn about it.
Right. So the editor itself is, we decided to write it in Visual Code, which is a Microsoft product. We're not pro Microsoft or anything like that. The reason we chose that software to do it. It was just because it's very high usage. It's probably one of the most commonly used IDEs out there. It's pretty quick. And a lot of the other editor, you have to pay for it. It's open source, and it's freely available. And then they have like a lot of libraries, and it's relatively easy to be able to update extensions. So we could add it as an extension into the Visual Code editor. So that was one of the reasons we chose it. We had used different editors, so we kind of switched to use it as well. And so I think that was a reasonable choice. We don't have plans to put it into any other editors, just because it's not really forcing anyone to buy anything to do it. So you can go and get the code, you can download it, and then you can just look up XBRL, or you can look up XULE, and in the extension library it'll come up, and then you can add it, and then you've got the XULE extension in VS Code. It's very, very easy to install and very, very easy to start using. So there are a number of users who are using it, like the Federal Energy Regulatory Commission, they're using it to write rules. And in their environment, it's very difficult to set up software, but setting up the XULE editor was by far and away the easiest thing to set up, because they were using code, they were using Microsoft Shop, so it made it very, very easy to use. So I haven't seen anyone have problems implementing it. It seems to work through, to do that install seems to work through most firewall setups pretty seamlessly. So in terms of using Visual Code, I think it was a good choice. I know Strumenta, obviously I'm not sure how much experience you had before that, but they were very good in sorting things out and getting things to resolve. There were some complexities in using it, particularly checking what taxonomies that were used and what were the elements that were there. So they did a good job doing that. So if you want to, you can set it up so that you can point it to different taxonomies so that you can check it. So it'll work with any taxonomy. So if you're in Italy and you're using IFRS, you can use it for that. It's not a US thing at all. So if you want to use it with any taxonomy anywhere in the world that's been published, then it will work with this tool as well.
Yeah, I think it's interesting the fact that there are so many aspects to consider when choosing a platform. Like, for example, you talk about how difficult is it to install certain custom software in certain environments. So maybe using something like VS Code that is widespread, make it easier, and installing the extension within VS Code, it's easy. And maybe also another reason why in a similar project makes sense, in my opinion, to choose VS Code is that it doesn't take too many resources, so it takes much less resources than other IDE that are targeted to developers. And the problem is that typically developers has more powerful machines that other users. So if you don't take this in account, your intended user could have problems actually using the editor.
And that's what we found at the Federal Energy Regulatory Commission. We laid it out to a lot of people. They were just really, there were various business users, they weren't developers. It could be installed on very low-end spec machines. It works totally fine. It's not power hungry in any way in terms of the memory or the processing power that you need.
Is there something that you have learned from your users about the language or the editor, or something that you decide to change after the first release of XULE or the editor?
We haven't changed very much at all. In time to time, things come up where we may need additional functions. One of the things about XULE is you can define your own functions as well within the editor. So, if you need a function to do something, you can just define that within XULE. And we've written a couple of those, like if we want to check like an ISIN is valid, which is a security identifier code, or we want to check that kind of thing. We actually wrote functions within the XULE syntax to do that. So, you can, a lot of that kind of stuff, which is very domain specific, you can write those functions. We have added some functions around regular expressions and looking up terms. So we've added a function for that in the underlying XULE processor. So, and we added a function. I think it was a trim function. We had a case where we were adding white space on the end, so we wanted to put a trim in there. And so we actually updated the underlying code that was provided instrumental just to add that function. It's relatively easy to add a function into the IDE, so it recognizes it and it comes up. So that hasn't been a problem. So, obviously, if we had to do a total redesign of the language, then obviously we would have to republish the IDE. But generally, most of the changes have been things like we needed to add a new property because we decided we needed this new property, like a trim on a string, or we wanted to add like regular expression matching, for example, on a string as well. That was just something we didn't have. And that just came up because, as more people wanted to look at string data, that was just another functionality that we thought we should implement. Most of that functionality, it follows, if you're familiar with Python, we've kind of modeled it in a way based on the way that Python handles data. So it includes like, its handling of sets and lists and dictionaries is literally identical to Python. So if you're familiar with Python, a lot of the terms are similar there, but we've tried to take the complexity out of it. So if someone's good at doing things like Excel functions, the stuff's not going to seem foreign to them at all.
Good. So it seems that your initial design of the language proved to be right, and so you did just incremental changes that, of course, are normal.
Very, very few changes, and it's interesting is we can handle it handles pretty much most situations, or pretty much all situations we've run into at this point. It hasn't really been, and if it doesn't, then maybe there is a better tool that you should be using. But in general, we wrote the language, we tried to be as inclusive as we possibly could and get every possibility that we knew about. And so I think that generally has worked. And there's been no, the only changes to the grammar has been to add like a property here and a function there.
Good. So it seems that the language is pretty stable. So I was wondering if you had any plan for the future, or new feature or upgrade, or do you think that the language and the editor works already quite well? And so
one of the things that we are looking at updating is in the XBRL world, they've released a new specification for CSV files, so you can express CSV in XBRL. And this means that some of the files you get are significantly larger. In fact, you could have files which are a constant stream of data. The way that the XULE processor works is it pulls all the data in, and then it runs validation on the data that is in a file, right? However, if you've got large continuous data files, let's say you've got a continuous stream of data coming in, let's say it's like real-time stock feeds or whatever it may be, but you want to validate those. And in some cases, you can't really wait until the entire file comes in, and the files are too large. So one of the things we were looking at was adding functionality to XULE for that, so it would be doing validation on the stream as it comes in. That has some implications in the sense that you have to write rules a little bit differently. If you want to compare things to aggregate totals, you have to be running like aggregators in the background as it aggregates stuff as it comes in. So that kind of stuff where we've kind of sat down and started to write, how would we write validation rules? If you've got a record came in, obviously you can validate that record, but if that record's got references to other files, then there's a sequencing type things that you need to address in the language as well. So those are some things we're looking at updating. That's one particular area, which is actually going to be quite a bit of work. The other thing we're also looking at is the ability just to bring in kind of like modules, I suppose would be the right word for it. So let's say someone's gone and written a bunch of functions in XULE. When you compile those rules, you've got to take all those rules and you kind of put them all together into a folder or a folder structure. It'd be nice if you could just reference those. Let's say they're on a URI on the web, someone's written financial functions. It'd be nice just to be able to import those when you compile the rules. So that's the other thing we're currently working on at the moment, is like an import function. So there's going to be a couple of things that will be relatively easy to do compared to the streaming stuff, which is a major deal. So we're kind of holding off on that for now. But the modules is something that we will probably be implementing in the next 2 months.
I don't know, it's interesting because I think that both streaming and modules are the kind of things that you may want to add to a language as it becomes more stable, more used, so it's part of the engineering phase. But
Right.
I think it's coherent with the fact that the language is proved to be well designed, and so it's getting more and more stable. So nice.
You know, one of the design principles is we don't want to make it too complicated so that you've got to have all the setup, and you know, and we want it to be able to people to be able to pick it up and be able to write it real quickly and then be able to do stuff. So, you know, there's trade-offs there. So we're constantly very aware that we want to try and make it as easy as possible for people to use. And, you know, people can look at it, and we've had people comment that not so much on the editor, but on the language itself. People have given, you know, we've made the whole thing is available on GitHub, so you can go up on GitHub. So we've had a number of comments from people who have been using it, particularly filing agents, company who run software. They have implemented it and using it on their site. And if they see issues or they see performance enhancements, then they're giving us stuff as well. So that's all good feedback. Technically, XULE is not an XBRL endorsed standard. So we've kind of launched this as like an open source initiative, just to give people a tool that they can use to manipulate XBRL data and produce output from.
Good. And I think it takes some discipline sometimes to keep the language simple and not just say yes, being too enthusiastic. Is there any other tool that work with XBRL that you think our listeners may want to look into?
So we've worked also with Altova, some of you may be familiar with, and they've implemented XULE in their XBRL package as well. That's part of their software solutions. So they've done it too. So we've got that. And then we're working with a number of other software vendors to help them try and implement it. Most folks who have implemented it have been software providers in the reporting industry, particularly in the US. And that's because they want to run these rules locally in their software before people file it with the SEC. So we'd publish them out. So what a lot of them would do is they may have a GUI interface where people prepare their filing, and then if they make a mistake, the rules are running in the background, and it'll come up and it'll say, hey, you've made an error here. There's something wrong. This doesn't make economic sense. Or, you know, we would expect if your liabilities are X and your assets are Y, that this would be within this range, or that you've reported an amount which shouldn't be negative. You know, how could this be negative? So those rules are kind of being incorporated into the software as well. So we're helping, you know, a lot of these software vendors provide that language into their software. And ideally, the way that the software should work, this is not always the case, but the way that the software should work is that they can then just upgrade those. We can publish out a new set of rules, and they can just update their software, then they'll have new rules in their software. So that's kind of the way we're trying to make it work. So it's not like everyone has to go and recode rules into their software. That's very, very inefficient. So that's kind of what we're trying to get to.
Yeah, so through collaboration with these software vendors, a lot of people can benefit from your work on XULE. So that's a very nice thing, I think.
Yeah, and it's been very useful for improving the quality of the XBRL data, so that particularly for the SEC data. So now that makes that data much more useful for other purposes. So people, you know, as that quality gets better, more people start to use it. People use the data. If they find issues in the data, they let us know. We'll add a XULE rule that'll get fixed. More people start to use it. So it becomes the cycle. But we kind of needed to do that. And having this language available has made, you know, the data quality much, much better. And, you know, Instrumental has been really helpful in terms of getting that editor. That's probably meant that we've been able to get 10 times more rules out than we would have otherwise been able to do. And it also means that the tool can be used by others. You know, we couldn't give this to people without having a nice IDE to use.
Thank you for for saying nice things about working with us. I appreciate it. And now we are reaching the end of our interview. So I wanted to ask if there is anything that you wanted to add, anything I forgot to ask you.
I think the only thing I would add is I think we're kind of just scratching the surface and some of the stuff we can do. We currently have projects that we're working on to take this data and then to normalize it. It basically means take this data that's reported in XBRL format and repackage it. The tool, the ability to do this is quite powerful, particularly when you've got lots of networks and things like, you may have heard about this, like there's people talk about graphs. And navigating graphs and doing data for that, graph APIs and all this kind of stuff. But XULE is actually, from what I've seen, is one of the best tools to do it. We spend a lot of time working out what's the best way to navigate networks. So we've put a lot of functionality into that. So if you've used tools in the graph databases, they have like some of these similar to SQL type queries, how you can navigate a graph. We've spent a lot of time. It's not like SQL per se. We try to make it as close to SQL as we could, so that people kind of, who understand that kind of concept of data can kind of make the mental leap a little bit easier. But then for the graph navigation, we've kind of tried to make it is similar kind of the way that you'd navigate a graph, right? I start at this node, I go down this node. One of the things that we have in XULE, which is really useful, is you can check the properties of attributes on those arcs, and then that can then control which arcs you go down. It also means, you can collect all the children of an arc, or the descendants, the ancestors, the siblings, if there's an implied order on them. So it gives you a lot of functionality to be able to manipulate or to navigate through those graphs and pull data out and then do stuff with it.
Yeah, it seems a problem that is not trivial because it's so abstract that provide a language that make it easy. I think it's challenging.
Yeah, and this is an area which is really going to explode probably in the next 5 years, particularly with things like AI is using these networks. And a lot more data is being described in this way, particularly, and I know people like talk about, Web 2.0, which kind of payment rates and how can you navigate this stuff. But I think with things like AI is bringing a lot of this stuff to the fore, because they kind of work the same way. And then building rich models, XBRL is kind of that, most people talk about things like RDF and using it, there's no real data available. But XBRL actually has a lot of data available now, which you can use, and there's always just a tool which allows you to be able to navigate all of that stuff.
Yes, and it's also data that has a very high quality. Well, also thank you to your quality checks, but I think this makes a difference with a lot of data that is available out there in other formats that is not really well polished or refined or so. Well, I would like to thank you a lot for your time and to sharing your experience with us. I think it's been very interesting also because the problems you're working on have such a scale where they are really worldwide relevant problems. So it was really a pleasure. Thank you very much for your time.
And thank you, Federico. Thank you for helping us out so much. I really appreciate all the stuff that you guys have done. And if anyone has any other questions based on this interview, you can go to our website, and we're more than happy to talk to you or anyone about this.
Good. And we will add all the links in the article. Yeah. Thank you. Have a nice day.
You too. Thanks. Thank you.